So we saw the example of Old Faithful for a one-dimensional problem where we have an input that's a one-dimensional value, and we map that to the output. Let's look at an example of a two-dimensional problem where we have for each pair, x, y, we have a two-dimensional vector x. So that means that we have for each object two numbers that characterize that object with which we want to then predict the output. So here's a very simple example of that where we have as an input a two-dimensional vector that has some measure of education and seniority. So for example, how many years of education do you have and how many years seniority do you have? That would be the input for an individual. And then the output is that person's income. And so that's we'll assume it's a real valued number. And so the model now is to predict the income of a person as the education of that person times some weight plus the seniority times some other weight plus some offset W naught. And so that's our two-dimensional linear regression model. And so let's ask a question first. What do these weights tell us? How can we interpret these weights? So first, both weights, we imagine that we have some data, we learn this model, and both weights are positive. What does this tell us? How can we interpret what these weights are telling us? So the answer is that as the education or seniority go up, income tends to go up, because for every unit increase in education or in seniority, we're multiplying that by a positive number, which means that we have an increase in the predicted income. And so this is just a way that we can then use our weights not only to predict an output, but also to tell us how the inputs relate to that output. And so as one caveat, we should say that this is not a statement about causation. So we're not saying that education or seniority caused the income to increase. We're saying, what we are saying is that these variables are correlated. So these inputs are correlated with the output in this way.